right, in this example, this is for section 6.1, the standard normal distribution. We're going to apply the same thing that we did in the last example, is using those formulas for z and for x for finding what they're asking for here, and then doing a little interpretation on top of that. Part A here, suppose a 15-year-old male from Chile in the time period of was 176 centimeters tall. What does it tell us about the individual's height relative to the population? So this is just a little slightly different way of interpreting the concept for z. And z looks at the number of standard deviations from the mean. So number of standard deviations above or below the mean. So what you want to do in regards to this is also the same way as looking at that as their whatever x value is relative to the population or relative to comparing themselves to others in that regard. So let me just take for example here and solve this one. So we want to figure out for z, we know that for this problem that x is equal to 176 centimeters. So let's go ahead and make that conversion for z. So we know that by the formula z is the data value minus the mean. We know that's 170 centimeters from the last problem, divided by the 6.28. So here, filling the blank for this, we're going to take the individual's height that is above the mean, so we know the z-score is going to be positive, and divide that by the standard deviation. We grab a calculator here, let's go ahead and do that. 176 minus 170 is 6, and divide that by 6.28, and here we get the point 9554, again 9554, being slightly above, almost one standard deviation above the mean. So this is just short there, but I'll put a note here. Almost one standard deviation above the mean. So, and that kind of makes sense is because, well, standard deviation is a little more than 6, so we're not quite there with 176 if we assume that the mean is 170 centimeters. Excuse me. So from this part, the height relative to their population, that it's only with respect to, given that the mean is equal to 170 centimeters and sigma is equal to 6.28 centimeters. So if those two parameters were to change, that changes everything. So if we looked and compared that number to other populations with a different, mean and standard deviation, of course that z value has a different interpretation. So where I'm saying we're almost one standard deviation above the mean, that's only true if we assume that the mean is 170 and the standard deviation is 6.28. Looking at for part B, we're going to do the reverse formula here. For part A, suppose that the height of a 15-year-old male from 2009 to 2010 has a z-score of -2. So I'm going to use the alternative formula here, like the last one, where we know that x is equal to z times sigma plus the mean. So what we want to do is fill that in, that z value, multiply that times 6.28, and then add the 170 centimeters to that. All right, so let's grab a calculator and do that. So we've got -2, multiply that times 6.28, and then plus the 170. And there we go, we got 157.44 even. So 157.44 centimeters. So that will do it. There we got part A and part B. Part A is the z-score, a little under 1 standard deviation. And then for part B is finding the data value given the z-score.